So we've already had enough exciting conversations this morning to make this whole day a success. It's just so wonderful and gratifying to have everyone in this room and to hear the things that have already been discussed, and we haven't even started yet. So welcome again to the European Trail Education Collaboration, and thank you so much to our esteemed guests from across the pond. It's such an honor to have you here. And yesterday we focused on the college, and today we're going to focus on what's happening in our region and also technology. And we're going to share with you some information, some student success, and then some application that we hope to include in our program. And that's from the product SimLog and ZSpace. We are supposed to start with NWAC project updates. And I need to say at the outset that the most important thing that NWAC will ever do with the generous gift that we've been given in this project is our students. And it is their learning and it is their success. And so it is my exceptional pleasure to share with you this morning that we haven't even started officially our trail program at NWAC yet, and we already have two brilliant minds thinking about what this gift is going to mean for our community and for the industry. And they are from our Ignite Professional Studies program, which is with the Bentonville Public Schools. They are they're both juniors. The Ignite Professional Studies program is for 11th and 12th grade students to gain valuable work-based learning experience, industry-valued credentials, and high-quality classroom experience. So they get high school credit while they do this, they get college credit while they do this, and they also get internship workforce experience. It's a brilliant model. And the strands in this program for students in the Bentonville Public Schools are aviation, construction management, culinary arts, digital media, education, innovation, engineering, global business, health sciences, and technology. And we were lucky enough to get two of the students in the technology strand. And we were also lucky enough to have a team member, Tara Bielecki, take on the responsibility and privilege of creating an internship from scratch for a program that hasn't even started yet, and try to bring students along in a professional way to say, what could this look like if we worked together and tried to be innovative on behalf of the industry and our community. And so I'm thrilled to introduce her to you. She's going to tee up introducing them. And again, this is what we're about. Students are what we're about. And so this is just really a beautiful thing.
Right, as Megan said, I'm Tara Bielecki. So on top of advising students here at NWAC, I'm also working on building an apprenticeship program for trail technicians and building an occupational code for that occupation on the Department of Labor end. When I was first approached about taking on high school students who are involved in technology, I had no idea how I was going to bridge that gap to trails. And never in my wildest dreams did I think we would be here today talking about what we're going to be talking about. So I just wanted to give you a little overview of what this internship has looked like on my end, what I've built for it, and what our day-to-day looked like while Harry and Vicki were with me. So everything happened in Google Classroom. We utilized Drive for all of our collaboration files. We could work together real time around the conference table. Harry sometimes put in hours on his own thinking about things, working in ChatGPT. And so it was always fun to come back together and know it was all in one spot for us. We also used Google Calendars, and we road mapped a timeline for all of our project milestones and important dates, and that got us here today. So this is just a little look at the classroom that I built, and I was able to put in, agenda for this week or important things we had coming up. Each week we had a slide deck and an assignment. So this was where we did all of their project management week to week. So they would come in, these slide decks were made many weeks in advance and were a passion project of mine for sure. And the first week it was really important to me that they understood our Trails Trade School, our why, what we want our outcome to be for our students when they leave this program. I also wanted them to understand NWAC as a whole and what our college's mission is to get students placed in the workforce locally and regionally. And then expectations for their internship with us. Not only what we could expect from them, but what they could expect from us and what they needed from us. During week 2, it was really important to me that we talked about trails, and week 2 ended up evolving into many more weeks of looking into trails. And they both come from very different backgrounds with trails, and they'll talk about that a little bit in their presentation, but I wanted them to have the same knowledge base about trails. And I wanted them to really understand the why behind trails. So we did a lot of research into the health benefits of trails, both mental and physical. We also watched videos about communities across the country who were struggling or had challenges to get trails into their communities, and how they worked with various stakeholders in their areas to make trails happen, and what that's meant for their communities on an economic development level, but also bringing people together within the communities. And Northwest Arkansas is such a great example of that. So I wanted them to see that our bubble here is fantastic. We're doing amazing things, but this is also happening across the country. This is also happening internationally, and it is a movement to get people on trails, and that trails are for everybody. So we also did a lot of research into multi-users on trails and why that's important to trail usage. The coolest part about all of this is when we first interviewed Harry and Vikki, we thought, we'll have them come in and help me with some data and organizing data for apprenticeship, and that's great for high school level thinking. And after our month of researching trails, they really took an interest into trail maintenance, and again, I'll let them speak about that during their presentation and why they were interested in trail maintenance. But we saw an opportunity for their curiosity and their innovation to be given a free lead. What would that mean to do trail maintenance with technology on trails, and how could we be thinking into the future about that? I think it's one of the incredible things about trails is that they can inform and create stories for each of us. And this time that I've spent with Harry and Vikki has really reminded me that our collective stories can also inform and create trails. So I'm very honored and super proud for Harry and Vikki to come up here and share their story about trails with you. So please help me welcome them up.
So a little about who we are. I'm Harry Ware. I've been mountain biking for about 7 years now. I grew up in this community and have fallen in love with the sport and the trails here. So when I found there was an opportunity to intern with NWAC and their Trails Technician program, I jumped on it and was super excited.
My name is Vikki Dullipalli. Unlike Harry, I didn't really have a personal background in trails or mountain biking at all, but one of my good friends really did. He tried to get me into that world, but he had an accident, so he wasn't able to do that. So this is my way of remembering him and moving on with his legacy in trails.
So the main problem in trail building right now is the trail maintenance piece, and the reason it's a problem is because no insurance companies actually will provide insurance for the trail building companies to maintain these trails. So it falls under land management to actually maintain these trails, and they have to get volunteers, which is a very sustainable option. So where we started trying to tackle this problem was we tried to create a robot that was actually able to go through trails and clear up drainage and ruts in the trail. And as you can see in the top left, we used AI to create that one, but we didn't like it because it was way too big to actually fit on a trail. So we tried to tweak that a little bit and get something a little bit smaller and make it actually remote controlled or autonomous. So that's what we kind of came up with on the top right, as you see. We also came up with a plan of a CAD LiDAR maintenance plan, which basically, if you build a trail and the initial, and you take a scan of the initial trail, and as its perfect shape, right, and then a couple months later or after a rainstorm or something, if you go through it and scan it again, it can use an AI software that can detect problems in the trail and send it automatically to the trail builder and say, hey, this is what the problem with the trail is. Well, we also had a meeting with trail builders. Shout out Uriah. Yeah, it was a super great meeting, and he kind of helped us realize that the main problem right now is actually a corridor clearing or overgrowth on trail vegetation. So that's kind of where we dedicated all of our research, and we had a couple inspirations when trying to actually tackle this problem. And the first one was this mower that you can see in the middle, and it's the Stella URS 100. So basically, it's a mower that can clear little small trees and like big brush piles, but it was way too big, and it was $50,000, and that's not really a low-cost option. So we took some things from that and kind of prompted AI to give us the one that you see on the far left, but it wasn't exactly what we wanted because it didn't look very reliable. So we tweaked it a little bit more, and we got the one that you can see on the far right. Well, the problem with this is it actually couldn't clear a trail in one run. So we were kind of trying to come up with a design that could, and that's when we had our friend Miles right here come in and help us out try to create a design for this.
So when we met with Miles, we created 2 design sketches. So the first design sketch, we created a base that was 2 to 3 feet wide and about 4 feet in length. It had tracked wheels and it had 2 arms on both sides because we wanted to clear out the trails in one go. And a mower type thing wouldn't be able to do that because we'd have to go around. So the 2 arms, the first sketch, we had it with like crush-like properties. So you'd be able to adjust the length of the arms by moving them between the notches. And there was issues with this because we wanted to make this accessible to everybody, but due to you having to physically be able to move the arm between the notches, it wouldn't allow people that couldn't do that to be able to like help with trails and stuff. And we want to make sure that everybody can do this. And that's where we came in with our second design sketch. We kept the same base, same like dimensions, same tracks. What we changed was the arms. We kept both arms, but we just changed the mechanism to move them back and forth. Instead of having like a crutch, we have like a car jack. So there's a ball screw on the end. We put a motor on that. So you can press a button on the controller that allows you to move the arm back and forth by rotating the ball screw. And this got rid of the accessibility issues because now you don't have to physically be able to you don't have to physically move anything between notches. You just have to press a button on the controller to adjust the length. And the arm stability issue that we had with the first one, we fixed that by soldering the arms onto the base instead of just having them connected, which that's what the first design sketch was like. And these are some of the parts we came up with throughout our research. These do include custom parts. We got about a rough estimate about $8,000 for most of these parts. And we'll talk about more of like how we're gonna end up with a better like total number or value for this. And these are some early models that we created after we moved away from like the mower type and more towards having arms with brush cutters. These are our early designs we had. We used ChatGPT and AI to do this.
And so after using those, we kind of finally came up with the Mullet TTR. We call it the Mullet because it's got business in the front and party in the back, the blowers, and it's kind of giving trails like a trim, right? So a little about this, like Vicky said, we're chosen to use tracks because it can tackle all types of terrain on all trails. And we plan on making this robot fully electric and sustainable so that we don't have loud machines in our trails. As you can see at the very top, that bar in the middle, that's actually a LiDAR 3D scanner. So basically, it's actually able to scan 3D around it on the trail so that it can map it, which we'll talk a little bit more on the next slide. And we plan on making this fully remote controlled right now because having a robot with blades all over it and riders, and even if you close the trail, you know how riders are. So we plan on making it remote controlled, but we did some work on making it fully autonomous, and that's kind of for the future of TTR. So first, we would need mapping data, so the LiDAR and the GPS tracking, which we're already going to have scans of LiDAR. And so that'd actually be able to map the trail. But second, we found this technology, and it's called terrain analysis. So as you can see in the GIF on the top right, so basically, this robot has a camera, and it has heat sensors, and so basically it's able to follow a trail in real time and very fast. And this is super exciting because it's actually like the future and like a really new technology. So to be able to incorporate this with trails, it's very exciting because it's so many possibilities. And so that's how we would actually be able to make this robot fully autonomous.
And going back to LiDAR, this isn't something that's completely new, as Ford has been working on a car that's completely autonomous through the use of LiDAR. The big thing on the car up there is a LiDAR scanner that all its surroundings can get checked and mapped to make sure it doesn't crash or anything. So it adjusts its speed, stops, moves around. So this isn't something that's we just made up. We did our research, and this is something that has already been in the works. So what's next? After we finalized our design and did our research, we wanted to work on the One Family Foundation grant. So right now we have a completed grant proposal. We just need to fill in some budgeting issues, all that stuff.
Yeah, so with the grant, we plan on sponsoring a design team through the U of A mechanical engineering department so that we're actually able to design and deploy this robot and actually allow trail builders, state parks, and land managers to actually use this robot. And finalizing our budget, we're soon about to finalize it. We plan, after taking into account custom parts, salaries, and all the things that would actually cost to make this robot, was around $250,000 for a 3-year span, so $750,000 total. And finally, underneath the week agendas, we have a letter of support, and if you guys don't mind signing those, just to say, hey, we support this, and it would help us a lot in actually finalizing this grant and getting it. Thank you so much, and if you have any questions, now's the time. Yeah.
So I just wanted to first of all thank NWAC, thank our international partners for being here and giving our students the opportunity to really present on an international stage. And we are just exceptionally proud of what they have been able to do, because as teachers, we can give tools and help foster things, but it's really hard to get that passion. And they have that so abundantly. And we are just super, super proud. From Ignite, again, we thank you.
Yeah.